Okay. All right, so let's let a of x, or let's see. Which function comes first here? B of x. So let's let b of x be the squared function. So now we've squared our number. What does that leave for a to do then? A has to multiply by 3 and subtract 7. So that would be one way of setting it up. What if we decided that we were going to let b do the double duty? Here he only did one thing, and a did 2. So what would this be? X squared. Wait. Now what has to happen first? X squared times 3. So he would be 3x squared, and then this guy would be x minus 7. You have to accomplish all 3 of those things. And if you only have 2 functions to do that in, then one function is going to have to do 2 of them. But it doesn't matter which one does 2 of them, as long as you got them in the right order. All right? So I don't want that to be confusing. Okay, now let's look at, in your packet you have a sheet called Random Practice. It's the very last page, actually, the very last page. And why don't you fold your paper, because I put the answers right next to it, so fold your paper so you're not tempted to look at the answers. Because I promise you, you won't have the answers next time you see this stuff. All right, we're going to sketch this without plotting points and without a calculator.
Oh, the very last page.
Very last page says Random Practice.
It's not on the back, it's the one.
The front of the very last page. Now we're going to sketch this without plotting points, without a calculator. What shape is it? It's a V. You know that because it's one of your BFFs. What have we done to the V? Remember, the normal picture would look like this. That's the normal. What has happened to this one? To the right 3, up 2. Very good, Kayla. Right 3, up 2. So there would be your picture. How long should that take us? 3 seconds. That's right. We know what we're doing. Now, again, another question about absolute value. Is it even, odd, neither, why? Well, I graphed the original absolute value right here. This is what you have memorized, that shape right there. Even, odd, or neither, you ought to be able to tell by looking at it. It's even. How do we know? Symmetric about the y-axis. If you want to check it algebraically, remember how we check it algebraically? We say, okay, if I input a 2, what do I get? A 2. If I input a negative 2, what do I get? 2. When you're even, it means changing the input does not change the output. That's what even means algebraically. Graphically, it means you're symmetric about the y-axis. Either one is fine for an explanation. All right, now we're going to do a composition. So we're going to find the composition C of H of S of 4. Now, when we talk about composition, we're just talking about doing functions consecutively. So we're going to start with which one? S. So we're going to put 4 into S. So what's S of 4? 2. What's S of anything? 2. It's a constant function. We just get 2. So when I plug 4 into S, I get 2. Now what am I going to do? So this right here is 2. So now what am I going to do with that 2? Put that into H. And I will get 36. So now this is 36. What am I going to do with that 36? Put it into C. And I get 73 as my final answer.
How does S4 go?
Yeah, no matter what you put in here, you're just going to get 2 out. There's no X over here to change anything, so you're just going to keep it at 2, no matter what you stick in. Okay, now we're going to graph a piecewise function.
I think it's just whatever order, so it's like C. Yeah.
All right, so here we go. What's the first piece of this function? If we just look at the top line, forget about everything else, it says y equals x plus 1. What is that? It's a line with a y-intercept of 1 and a slope of 1. So there it is. Now that's the whole line, right? That's as though I just found y equals x plus 1 and I sketched it. I don't want the whole line, do I? I only want the part of the line from here down. Why is it down? Less than? Going to the left. I'm going to erase all this. Now what about that middle line? Don't let this be confusing. What does it say? Y equals 3 if x equals -2. Well, wait a minute. That says x is -2 and y is 3, right? That's it. There's one value for each. 1x, 1y. Y is 3, x is -2. So that's going to get plotted as a point. Gives me one y value, one x value. That's 1 point. Okay, what's this? That's your parabola. And just so I get a good shape here, I'm going to go ahead and plot a couple of points. Very nice shape. So there's my parabola. Do I want the whole parabola? Nope. I only want the part that's bigger than where x is -2, to the right of where x is -2. So I'm going to erase that part. And I want this part of the parabola. That's where the x values are bigger than -2. And there we go. Now, what's the domain of that figure? All real numbers. Here's your domain, kids, right here. It's laid out for you. That's all real numbers. Range is a little bit tricky. Look at it carefully. Which y's have we graphed? I see it going up forever and ever, and I see it going down forever and ever. So I'm tempted to say all real numbers. But there's something wrong with that. What's wrong with it? There's a gap in the middle. Do you see that? So certainly our range is everything greater than or equal to 0. Would you agree with that? Or everything less than, let's see, X was -2, so Y is -1. This is the point -2, -1 from that equation. So everything less than -1. That's the range. Okay? Domain. Okay, we just have to know this. What am I thinking about when I look at problem A? Whatever is under the radical has to be greater than or equal to 0. It cannot be negative. It has to be greater than or equal to 0, which means X has to be greater than or equal to -5/3. B, what's the domain? All real numbers. Why is the domain all real numbers? No denominator, no radical. No denominator, no radical, no issue, unless it's something like a logarithm or something weird. C, what's your domain? X cannot equal 5 because the denominator cannot be 0. For number 3 above, what is the domain of C of X plus H of X? What would the domain of that be? All real numbers. What is the range of the identity function? Stop and think. What's the identity function look like? What is its range? All real numbers. Jamie?
For number 6, why wouldn't it be X is greater than or equal to -5/3 and X equals 5 if it's just these two? I don't get why it's all these.
Okay, it's back to number 3. This is function C. This is function H. Right?
Yeah. I was thinking
But yeah.
Number 8. What is the range of the absolute value function? Remember, it looks like that. So what's its range?
Y is greater than or equal to 0.
Y is greater than or equal to 0. Sketch the cubing function. Everybody needs to know what it looks like, right? But you need to know what they all look like. But that's your cubing function. Correct? All right, now I want to do one more problem here. All right. All right, let's fill in this information. Just that. All right, here we go. How do we start this?
Is the sum of the paper?
This is made up. What do I have to do here? My job is to find all this information. So what am I going to do? I'm going to start factoring it, right? So I can take a 3 out. So my top will factor as x minus 3 plus 1. And how does my bottom factor? Plus 3 minus 3. Uh-oh, and then I notice what? I'm going to have a hole, so I'm going to rewrite my problem in its simplified version. And then I'm going to step over here, remembering that all of these are points. The hole is a point. I'm not going to write x equals something. I'm going to write an ordered pair. And what do I know about that ordered pair? The x is 3. How am I going to find the y? Plug in 3. How do we always find y? We plug in x, right? So if I plug in 3, I'm going to get 2. So if I were graphing this, and remember, you do not have to graph it, but if you were, you would have a nice open dot at 3, 2. Because that's what you canceled out. All right, what else can you tell me about this picture then? Bailey? What's VA stand for? Vertical asymptote. And what's my vertical asymptote? X equals -3. Remember, these are lines. So if you just put -3, you're going to not get full credit. The vertical and horizontal asymptotes are lines. And why do we have a vertical asymptote at -3? That's what makes the denominator 0. That's what x cannot be, right? The equation is x equals -3, but that's because x can't be -3 in the problem. All right, what else do we have? We have a horizontal asymptote at y equals, what did you say? 3. Right here, I can look right here. There's my horizontal asymptote. All right, what about my intercepts? To find the intercepts, you're going to let things be 0, right? Keep in mind that if you're on the x-axis, y is 0, right? So your x-intercept, you're going to let y be 0. If you're on the y-axis, x is 0. Those are points. To find the points, you just let each letter respectively be 0. So if I let y be 0, to find the x-intercept, if I let y be 0, I'm going to solve this equation. What do I get when I solve that equation? X equals -1. Remember, we're not going to be confused by this. We're going to multiply this over here. It's still 0, and then we're going to solve that equation. X equals -1. And then I'm going to let x be 0. So x being 0 would give me 1. Now, that's all you are responsible for at this point, but actually you could sketch it, just connect the dots, and there is your picture.
How come I got x equals -1/3?
For what?
When you find y, you put, or when you found x, you put y for 0.
Okay. Put x in for 0?
No, wait. When you find, when I found the x, I put the y for 0. And then I multiplied the x for both sides, so 0 equals 3x plus 1. 0 equals 3x plus 1, subtract the 1.
Okay, did you distribute here?
Yeah.
So it would be 3x plus 3.
Okay. Oh, and then you. Okay,
Right.
sorry.
That's okay. All right, let's see. Next. How about this? Hannah. Sorry. We don't really care about that. All right. All right, let's take a look at these functions. I want 3 things. I wanna know the name, the domain, and the range. So I've just picked 3 of your BFFs. I want the name, the domain, and the range. All right, what's the name of this one? Logistic. What's the domain? All reals. What's the range? Between 0 and whatever this is, you're supposed to know that's 1. It's between 0 and 1. That's the range. Notice these are not included. Why are they not included? Because they're asymptotes, right? We're not touching them, we're just trapped between them. All right, what's this one? The name, cubic function, its domain, all real numbers, and its range, all real numbers. What's this one? It's a cosine function. Pay attention. It's a cosine function. What's its domain? All real numbers. What's its range?
1.
Between -1 and 1, and I include those, don't I? Because I've got dots at -1 and dots at 1. Okay, got it? Okay, I reserve the right to ask you anything I want about the BFFs. You need to know them. Domain. X can't be -5. Right? Domain. X is greater than or equal to 2. Right? X is greater than or equal to 2. Domain. All real numbers. No fraction, no radical, no problem. Okay. You have, okay, the page we just did that was random practice, look at the back of that. It says extra review. Again, hold your paper so you're not tempted to look at the answers. All right, so here we go. These long periods, I need to stop and start this thing.